So we know what it means for one integer to divide another integer. And along similar lines, we have this theorem called the division theorem. Also known as the division algorithm. Despite being not an algorithm. So who knows where that n came from? But okay, what is the division theorem? The division theorem tells us that, okay, we know that we cannot always divide one integer by another, but there is a general expression that we can write for any pair of integers, like so. Let a and d be integers with d different from 0. Then there exist unique integers, q and r, such that r is between 0 and d, but strictly less than d. And we can write a equals q times d plus r. So q is the quotient, and r is the remainder. This is why we're using q and r. So the proof of this is not too hard. I will make that an exercise as well, but I will give a little clue as to maybe what is a good way to do it. But instead, let's talk through some examples. So first of all, to connect this to what we just said, let's observe that r equals 0 is the same as saying d divides a. So here's another way of saying this. D divides a if the remainder in this expression is 0. But this is a little bit more general. You can say it for any two integers, except that you might potentially have a remainder. So what about when r is not 0? So let's take just some integers. Let's take a equals 100 and d equals 13. So to find this expression, we're basically asking what is the greatest multiple of 13 that is less than 100? That's what this condition that r has to be in this range means, essentially. So what is that? Well, maybe we happen to know that 7 times 13 is 91. And this is, if you believe that multiplication, you can see that this is the largest multiple of 13, less than 100. And the difference, as you can see, is 9. So we get 100 equals 7 times 13 plus 9. So this is a equals q times d plus r. Let's do another quick example. Let's say a is 80 and d is 3. So I want to approach this from a slightly different angle, because next we're going to start talking about situations where we're less interested in q and more interested in r. So 3, you may remember that there are certain tests for determining whether a number is divisible by 3. In particular, there's this test that if you add up the digits, then that thing should be divisible by 3. So 80 is not, because the digits add up to 8. So let's take a step down and see when we get something that's divisible by 3. So 79, the digits add to 16. That still does not work. 78, the digits add to 15. So that works. So 78 is the largest multiple of 3. Less than 80. So we can write 80 equals q times 3 plus, what is the difference here? 2. And if we're curious to figure out what q is, I think q turns out to be 26. My arithmetic is correct. So here's another example. 80 equals 26 times 3 plus 2. But next we're going to be talking about situations where we're forgetting about this quotient and only paying attention to the remainder.